Hello everyone and welcome to a new video. So this is sort of a new experiment. Basically, I was looking for inspiration on something to cover and I was on YouTube and I was looking for audiovisual max MSP and I found this video which is pretty nice from a YouTube channel called How OCD, and I found out he's even using some of my tutorials, which he even put a link to the video. That's very much appreciated. And I was looking at this very nice audiovisual performance, which is made with Max, that is both audio and video generated in Max. So let's take a look at the part I'm interested into, this one here. And I thought it would be cool to recreate something similar, like to show how would I go about recreating a similar effect. So that's the effect I'm talking about. Let's give it a look. Yeah, basically having this square with the image moving around in the window with these lines that look like they are projecting the squares, and this look like some sort of noise. It's definitely some GGL BFG noise. And yeah, that was the part I wanted to recreate, and I did it in this way. There is even a bit of audio stuff. Let's hear it. Sounds like this, nothing to be too excited about. But I wanted to kind of show you how I would go about recreating this part of the video, this effect. So, if the author of this video takes a look at this video, then would be great to receive some feedback. Tell me if you are okay with me recreating a portion of your video, or maybe not. Maybe this is even something, I don't know. It would be cool to hear from the guy. In any case, you too, my dear public, let me know what you think about this video, and maybe I will do more of those in the future, like when I see something that I like on YouTube, or some audiovisual art, which is full, by the way. But if I see something that will be kind of nice as a studio to recreate, then I will give it a go. You can, of course, suggest me also things that you would like to see me working on. Anyway, without any further ado, let's jump into the coding. Have fun. First thing, we are going to create our audio part. So first we need a DAC to have some audio in output. Give it to the message start window, so it will start only this max patch audio, and then we can stop it. Let's create our live gain to check that the volume doesn't get out of control, and connect the left and right input of the DAC to outputs of live gain. Good, and then we make a simple audio thing, which is basically just going to be a cycle, and the output of this cycle is going to be multiplied by an envelope, which we will create with ADSR object. So we will get like 1 second for the ramp up, 30 seconds for the ramp down, 0 volume for the sustain, and 0 for the release. So this will just give us a quick ramp up and a quick ramp down. And then we basically want to maybe clip the audio so it never gets above 0 and 1. So we can even get some little distortion with that. And then connect the clip output to the first and second input of live gain. So let's start the window. Let's see. Of course, there is no frequency for the cycle, so let's give it something. And actually, we also need to send the message 1 to the IDSR to start it. So let's do like this. Let's trigger a bang, which is going to simply trigger a glissando frequency for our cycle, which let's say they can go from, I don't know, 3000 to 1000 in 10 milliseconds, something very fast, just like a fast sweep. And then the 1 will go to the ADSR. So if we now bang that, we should hear something. Yeah, there it goes. There it is, our sound. It's kind of a beepy sound. If we make this a bit longer, we should get a bit more the sweeping effect. Let's see, if we make this like 50 long ear and 50 long ear. Yeah, something like that. And we don't want to focus too much on the audio, it's not really the point of this video. And then we want to trigger this bang at random intervals. So let's create a random 100, which will set the timer for a metro, which we basically want to be active by default. So active 1 it's going to be. Of course, this doesn't have any time at the moment. Let's give it a time of at least 100 milliseconds. Got a toggle to stop it, and then with this we'll trigger the random object, and then we will give it a little f offset, like a 50 milliseconds, and we will connect this to the input of the metro. So every time it emits a bang, it also set randomly its new interval before the next bang. So this will be a bit more random. Okay, we can also create a couple of float numbers to just make this a bit more, to just have a bit more control about that. Great. Maybe actually let's keep this low as to 10, and maybe let's keep this also low to maybe 30. I just want to have a little percussive sound, something like that. And we can also modify the offset actually. Yeah, we can play a bit around with that. Good, so now let's go into the video part. So I will just create my JIT world, and I will call it main, and I will give it a full scale anti-aliasing one. I will give it floating one. I will give it the raise color to black for the background. Size of the window to be, you know, 200 by 200, doesn't really matter. And maybe I will give it also an FPS of 120, because it's always good to have an high frame rate when we are doing audiovisual stuff, because then the sync will be much more precise, although 60 frames per second should be actually enough. I want to enable it, so I will give it enable 1. By default it's going to be enable, and I'm going to take the display link out. So if your monitor has a refresh rate that is lesser than 100 frames per second, this is going to nevertheless give you 100 frames per second, because you are decoupling it with the refresh rate of the monitor, so display link 0. Cool, so that's it. This is rendering at the moment. Now I want to just get an image that we are going to display for our effect, and we are going to put it inside a GGL video plane, which throws to main, which is scale something like 0.2, and that's for the moment it. We need to give it an image, which I will create with JIT GLBFG, to which I will give basically, yeah, I will give dimension 512 for the internal texture. Basis, I'm going to just get noise simplex, just very fast to calculate noise. Then I'm going to give it the attribute colorize one, because we want to have a colorful output. So let's check if we get already something in output from JIT-BFG. If we just click here, yes, we get something. That's great. Good, so we want to trigger that image and send it inside GGL video plane. So here we got our video plane. This is our image that we are using for our effect. Could be actually whatever image. I'm just using the noise because that's kind of what the artist in the video that I showed you did. So that's I want to exactly to recreate similar effects. So we are going with that. Okay, so now every time we trigger a sound, we're going to trigger some events around in the patch. So let's create a sender for this, which we can call audio bang or something like that. Let's actually get rid of this graphical bang object. So here we can trigger every time there is a new bang. We want to change, for example, the zoom for the GGL BFG. So we can say zoom $1. And we can choose a random number between 0 and 10. So maybe between 1 and 10. No, maybe between 0.2 and 10. 0.1 and 10. And 9.1. So let's actually make it to 10 with random 11. So this will go like this. We'll trigger first this random message, which goes into the zoom, and then we want another random object to change the time of the GGL BFG, so to get in another part of this function using this parametric value. So let's get just a big number like 10,000. This we are going to use as our time. It just needs to be a random number, really. So this is going to be our time. And then we finally want to, they must be connected, of course. Then we finally want to trigger these GGL BFGs, so we get an output. And now you can see that every time we get a new sound, this image is being changed. So let's hear how it sounds like and see if it's already kind of, we get the synesthesis between audio and video. It looks good, it looks good. So now every time we get a new sound, we also want to actually move this video plane around in our window according to how wide is the window. So in order to know how wide is the window, we need to get the attribute size from our JIT world. So we can use the getAt object and get the attribute size. Connect the first inlet to the middle inlet to the JIT world. From the middle inlet, we will get the size of the window. As you can see, every time I modify the window, we are going to get a new couple of numbers. This is the size of the window. So in order to get the ratio of the window, so to know how wide is the window in world coordinates, basically we need to divide the x by the y, and then we can send this number around in the patch with a sender. And we can use that basically to trigger a couple of other random objects. This will go between 0 and 100, and let's create another one. And then we are going to scale 0 to 100 into -1 to 1. It doesn't matter because we are going to change this number using the window ratio. So this we're going to multiply first by -1. Remember always the dots. This is a common mistake to miss the dots. It always must be a dot if you want to have a float number as an output. So this will be our new maximum output. This will be our new negative output. So on the left side of the window, and this will be the position on the right side of the window. So let's modify a bit the window. Or simply send a bang to the getAt object. So it will fill. As you can see, it will send a number out of here, which is the ratio of our window, and fill the new minimum and maximum for the scale. Okay, great. Basically, so here when we get the audio bang, let's copy the receiver for the audio bang. We want to trigger a couple of times these random objects. This is going to be the y position, so we just want to scale it, for example, between -0.5 and 0.5. This is a bit like the effect looks in the video. It looks a bit like if this window only moves in the -0.5 to 0.5 range on the y, so that's cool. We will keep it as well in this range, so let's then create a pack object, so with a C, because we don't want to trigger it every time it receives a number, but only when a certain event is triggered, which is our audio bang. So let's say position FF0 for the zeta. So this is going to be our y position, this is going to be our x position, and we want to attach this to the video plane. Can actually put the whole thing a bit down here. And then we want to actually trigger the pack, so we can create here another bang. And this will be the last bang that is triggered and goes to the pack. So now we have the window moving randomly in the screen every time we trigger a new sound. So let's hear and look at it. Okay, this looks pretty good. It is slightly a bit too far out in the screen, and that's because maybe we want to take our camera a bit farther from the shape. So let's create a GGL camera that draws to main, and then let's assign its position as maybe we can give it a value of 6 for the zeta axis. Oh, maybe that's a bit too much. Let's keep it to 4 or to 3. Yeah, something like that. And this looks pretty okay. We can maybe make our video plane a bit bigger. So instead of scale 0.2, let's say scale 0.3. And there it goes. Okay, cool. So now we want to create the red lines. We want to create these red lines that connect kind of these point in the depth to to the image. And then I even go further, actually. Okay, that's pretty cool. It's like if it's being projected from that point. So let's do it like this. Let's first actually pack this into a sub-patcher, video plane, position, and then let's go here and create. We're going to do the lines with a GGL mesh, which draws to main. The color is going to be red, so color 1001, and then draw mode is going to draw lines. So lines it is. Good. Now let's create a JIT matrix with 3 planes, float 32, and let's have 100 of these lines, these red things. Actually, it's going to be 50 because every line is 2 vertices, so one vertex will be just this point in the background, and the other 50 vertices are going to be the points that go toward us. So let's then create a JIT gen and connect these to JIT-GL mesh. Let's actually create a sender for the metro that goes out. Let's call it metro world or something like that. And then let's connect it to this JIT matrix, because we need to trigger that at every frame. We don't need to trigger that at every frame, actually. We could trigger that at every audio bang as well. So let's see, for the moment, let's just trigger it at every frame, then we see if it's not necessary. It's probably not necessary, but let's see. So let's go inside JIT-gen, and what we want to do is to say, so one cell every 2 cells, we want to keep at the bottom. So this point at the bottom of our world. So we're going to do like this. We're going to create the cell object, which will give us the index of the current cell. And then we're going to say width x. It's anyway just one coordinate because our matrix is only 1 dimension, but let's nevertheless just width single component. Let's make the module 2, so every time this index can be divided by 2, this is going to give us a 1. So we can use, otherwise it's going to give us a 0. So it will go like this, like 0, 1, 0, 1, 0, 1, and so on. So this is we are going to use that as the condition to test for this ternary operator here. And in case the number is 0, we want to set just a fixed vertex that will be on the bottom of our world. And in case the number is 1, we want to then maybe get just a random number. Yeah, we can switch the x and the y component of the random number that is created every time the JIT-gen receives a new matrix, and this creates as many numbers as planes in the input matrix. So it's going to be 3, but we just need 2, so we switch the x and the y. We pack that into a vector as well, and this is going to be the x position of that. This is going to be the y position of this vertex. For the moment, let's just make the zeta value 0. So now we have that these lines are starting from the bottom and are coming all the way up to that 0 position. Let's actually move around our camera by creating a JIT-anim.drive with UI listen, ease 0.1. Don't want to ease so much. Let's connect it to the camera. Let's actually give to the camera the look at 0, 0, 0. So we will always look at the center of the world. If we lock the look, let's give it also tripod 1 so it will not get inclinated. And as you can see, if I move my camera around with the WASD keys, we have that these lines are going from these points in the background to the 0 position, where our video plane is at the zeta axis. It's the same zeta axis of the video plane, the 0 position for the zeta. And what we want to do now is to basically, since it's only going to the positive direction, because noise only gives us numbers between 0 and 1, we first want to scale that from 0 to 1. We want to scale that to -1 to 1, so we are going also in the negative direction. And now, since we want only these these lines to look like they are projecting this shape, we only want to restrict them to the scale of the shape. So we can actually then multiply this by 0.3, which is the scale of our video plane. We could have just scaled this by minus 0.3 and 0.3, but this kind of makes it more clear. Good. And then we want to basically sum to this position the current position in the world of this video plane, so we can map basically these lines to the position of the video plane. So let's go here and let's create a pack object here that is going to pack down these two numbers, the y position and the x position. So we are now inside the position subpatcher. We're going to send this out as a video with plane pause, something like that. And then we're going to receive that here on our main patch, and we're going to prepend these two numbers with the plane pause message. So when we go inside, if we send this inside JIT-gen and we create a new parameter that we call with plane pause, and this is a parameter with two elements, so it's a vector 2 basically. Let's delete these errors, and then let's sum that to this position. So since it's anyway a vector 2, is only going to sum the x and the y, and there we go. We have that our lines are projected onto the video plane, so it looks like the video plane is being projected by those red lines. Actually, in the video, I think the lines go even beyond the video plane. Yes, something like that. So let's make them a bit go a bit more beyond. Let's first them start from even a point even farther on the backspace, and then let's send them on a point that is a bit farther than the video plane. Oh, but of course, in this way, we get that the lines are narrower when they intersect the video plane, so that's a problem. Let's actually make it just 2 maybe. Okay, so that's a problem. We need to scale that a bit more, and I guess we just need to multiply that by 2 in order to have this correct. No, okay, so what we actually need to do is to multiply by 2, because we double the length of the lines. So after we sum it to the video plane pause and before we set the zeta position. So I think we can do something like this. Should actually get sum these first. To the video plane position, then multiply this by 2 with the whole video plane position in it, and then we can add a zeta position to this vector, which we should be able to do by simply writing concat 2. So let's give it a try. Now this seems to be wrong since it's not getting the zeta, so let's actually do it the usual way. We will just switch the y and position and connect them to the x and y component of the vector. Okay, great, and this should be a zeta of 2, right? So let's give it a try. And this seems to be correct. So now we have these... the lines are going up beyond the video plane, actually to the direction of the camera. Let's add a bit of blending for both the lines and the video plane. So we will go like this. We will say blend enable 1, depth enable 0. And the blend we will say add. We will do some alpha add blending. So we will add the colors. And I guess we want to say that... the lines here will be always on top of that shape, so let's do like this, blend enable 1, blend add, depth enable 0 again, and since we want the lines to be on top of the video plane, we will say layer 1 for the lines. Okay, so this is how it will look like. Let's take also the opportunity to reduce the color of the lines to 0.5, so we will have a better kind of blend add effect. I feel like this is a bit too much. I add a bit of red, green and blue in order to have a bit of summing also on the other channels. Okay, something like this is starting to look good. But if we look at the video, the lines are actually only on the edges of these squares, and so they are not inside the square, but they are just on the edges of the square. And this is a cool effect that we could recreate. So we can go like this inside JitGen. We want to do this. We want to say, basically, let's take just a random number with the noise, and then we switch just this X component. And we say if this is greater than 0.5, then we can use some ternary operator. If this is true, just send out the normal number, so the number as it is. But if this is false, just send out the sign of this number. So this will give us always just -1 or 1, because it's the sign of this number that comes out of here. This vector can either be -1 or 1, so it can either be positive or negative. So this will give us a -1 in case it's negative and a 1 in case it's positive. So let's go like this. This is a nice trick we can use in this case. And then for the y, we want to do the opposite. Actually, so this should be then multiplied by 0.3 after that, because we want to do this both for the x and the y. So like this. So if this is false here, and so this is going to be the opposite. So either the x or the y are going to be -1 or 1, and the other one is going to be simply the random number. So that and that should work. So exactly. So now we have this cone of this square cone that is contains our video plane. Okay, so that's a cool effect. And let's give it a look with the sound as well. Okay, so this is starting to look pretty cool. Then going on with our analysis, we can see that first of all, this is only on one side of the screen, but this is actually kind of a minor detail. And then we can see that there is always a vertical, an horizontal line, red horizontal line, which is kind of cool. And also what I just noticed is that this image, the video plane, is either below the line or above the line. It's never in just a random place in the space on the y axis. So what we want to do is to go here when we set the video plane position, and for the y position we just want to do like this. We just want to get a random 2, so it's either 1 or 0. And let's do like this, select 0 and 1. And in case this is 1, we are going to trigger, let's try with the, in case this is 0, doesn't matter really, we're going to trigger 1. And in case this is 1, we're going to trigger -1. Let's see if this is okay. Okay, no, I think the actual number is 0.5. We have to, exactly, we should actually just set 0.5 and -0.5. Let's see. And of course we also need to send that to our pack object, so like this. Exactly. Okay, so this looks good. The image, the video plane is either going to be at +0.5 or at -0.5, so that's more similar to the video. We can add this horizontal red line. This is going to be very easy. For that we're going to use another GGL mesh, I guess. And let's just give it, let's not even give it any blending, let's just give it a color of red, and just a matrix with 3 planes, float32, only 2 cells, because it's going to draw a line, so we just need 2 vertices. Let's actually say draw mode lines. And what we need to do is to basically set cell 1D 0 as minus, let's say minus 3. Let's make it really long. Anyway, it's never going to be, let's say actually minus 10. Anyway, we're never going to see the end of it. So set cell 1D, and this is the index of the cell, and this is the values for that cell, so 3 planes. And then let's say set cell 1D, the second index, and then 10, 0, 0. And then maybe let's bang this matrix. So there we got our line, horizontal line. Okay, cool. I think actually what I want to say is not minus 0.5, but actually 0.3 minus 0.3, since this is the scale of our video plane. Yeah, exactly, this is more correct. Okay, so now it can either be below that line or above that line. Okay, cool. So yeah, now this is starting to look good. And okay, let's do just one other thing before we wrap it up. Maybe we can add like some sort of a background to the like a band in which our video plane moves. So we can do that simply with a grid shape. Let's set shape plane scale. We're going to set it 0. Let's say 10 for the x, 0.3 for the y, 1 for the z. It doesn't really matter. And then depth enabled 0, and then layer -1. So it's always going to be drawn first. Actually, we want to set it at 0.6 exactly. Cool. And then we want to maybe give it a nice color, maybe something bluish, something like that. I don't know. Yeah, it doesn't really matter. Something that looks cool. Yeah. Okay, so this looks good. Let's give it 1 second, and I'm just to look at it. 1 second. We can maybe try to change a bit the sound, make it a bit more like a kick, or make it something else. Okay, so this looks pretty cool. Oh, actually, before we wrap it up, let me add another thing, which is a GGL pass. And we want to say fx name. I want to add a bit of bloom, so bloom IQ, and the threshold, I want to set it to 1. So yeah, and maybe let's set the threshold to actually 1.1, so only the color that a blend added will bloom. And actually let's give a color to the video plane of 1.1, so more than white, so it's going to be seen by the bloom object. This should actually work. Let's say actually 1.2, 1.2, 1.2. Yes, okay. And now it's blooming. Nice. So let's watch once again. And cool. So this is it. I hope you liked this video. This was an experiment, and if you liked it, we will do more of these kind of things. Otherwise, yeah, let me know what you think about it. If you liked the video, it would be great if you put a like to it, you follow the channel, check out the Patreon. And yeah, let me know especially what you think about this sort of videos, or if you have some special requests, maybe you want to submit a video yourself, and then I can give it a look. Okay, so thanks a lot for following, and I will see you in the next video. Ciao!